operations on numbers expressed in scientific notation. So we're not doing anything new. It is just more practice. This is a different way to look at numbers. And so since we are looking at numbers in a different way, that means that we need more practice. All right, so this is a practice lesson. In the last lesson, we only worked with really big numbers because we were working with space. As I look into number 1 up here, what kind of number do I have here? It's a really small. How do I know that this number is really small and not really big? Yep. Because it's behind the decimal. It's 0.0000000, lots of zeros at 1672622 kilograms. Okay? So because it's behind the decimal, that means that we're working with a really small number. Number 1, in scientific notation, it is. What were the important non-zero numbers that you used in your decimal answer, Sedlick? Okay, well, that's all right. You can do it now. What are we need to write a decimal for the scientific notation part. What is going to be the decimal portion of your scientific notation number? What numbers do I need to include in my decimal? All right. And with those important numbers, where does my decimal have to sit?
Sorry.
I'm writing this number in scientific notation. You have written right behind the 1 because in scientific notation there's always one and only one number in front of the decimal. Now I have to include the decimal movement from where it currently is to where I have an end. Who figured out, Hoyt, what is the exponent I'm going to attach to this number, and how did you come up with it? Okay. What does the exponent represent? How many times? What?
10.
Why did you say 10? Where did you come up with that number?
I don't know.
Okay, what does the exponent represent in scientific notation? Okay, he said the number of zeros. How many of you agree that the exponent represents the number of zeros? Okay, it doesn't represent the number of zeros. It represents what, Landsberger?
I don't know.
Kearns?
How many times the decimal gets moved?
How many times the decimal point moves from where it currently is located to where we need it to end? Okay, so how many movements, Hoyt, does the decimal make? I got 27.
Yeah.
27 movements? Okay. So it moved 27 times. Now, Hoyt, what kind of a number this is? What kind of a number is this? A really small one. And because it's a really small number, what does that mean about my 27 movements? It needs to be negative. Okay? We're representing a very small number. There were 27 decimal movements, and it is a negative 27 because it's a really small number. Questions on number 1? On your mark, set, go.